Welcome to Natural Habitat Adventures Daily Dose of Nature. Today's topic, meet the beguiling belugas of the Arctic, presented by NatHab Expedition Leader Eleanor Edye. I'm your host, Rob Mess. Thank you so much for being here with us today. Take it away, Eleanor.
Thanks so much, Rob, and hi to everybody joining today. Like Rob said, my name is Eleanor. I'm one of our Canadian expedition leaders here at Natural Habitat Adventures. And as part of my role as a Canadian EL, I work on our beluga program up in northern Manitoba. So I'm excited to be here with you today to talk more about the belugas. I'm using this webinar to get super excited about the summer to come. I hear there's some summer weather coming at people already, so hopefully you're ready to think about the Arctic and Arctic whales for the next hour or so. Now, there's a lot to talk about where it comes to belugas. We certainly can't cover everything in an hour. I'm going to kind of give you an overview, some pieces of their conservation and their ecology and their basic biology, and try to leave some time for questions at the end of the webinar. But by the end of this webinar, you'll certainly know why the white whale in this picture isn't actually white, if you're not already aware. So let's move on and talk about an introduction to the beluga whales. So as you can see here, there are a whole host of whales in this image. Around the world, there are around 90 species of whales that are extant, meaning currently living globally. We say around 90 because sometimes we don't have an exact number. Every so often, certainly rarely, but every so often, there's still a new species that may pop up that was previously unknown to us, especially those deep diving whales. And there's also new genetic evidence that might come in to split different populations into different species, for example. But anyway, let's bring it back to the beluga. So I say whales here, and this image here says whales of the world. If we want to be more proper about our language, we would call them cetaceans. So cetacean is kind of that umbrella term for all of our whales, dolphins, porpoises, all of which, like all of those whales, dolphins, porpoises, those are human divisions. They aren't really biological divisions. So whether you want to point at something and call it a whale or a dolphin or a porpoise has more to do with how we perceive it and how like we look at its shape and what it eats and what its teeth look like, as opposed to like how it's actually related to other animals. So all of them together are, right, they're all mammals, which means that they're all homeothermic, so they maintain their own internal body temperature. They give birth to live young, they lactate. They do have hair, often it's just a few little whiskers around the face, and they breathe air. So all of these are air-breathing organisms, even the deep divers, and they are all, including the beluga whale, carnivores. So they're all within that larger order of carnivora. The scientific name for the beluga whale, you got the blue arrow pointed at it here, it's Delphinapterus lucus, which means white whale without a fin. We'll talk more about that in a bit. And it belongs to the family Monodontidae, which is a very small group of whales, which encompasses just the beluga whale and the narwhal as currently living examples in that family. I like to pause here in a second for this picture and to really consider it because it has a lot of information, and for me as a biologist, it also throws a lot of species at me that I'm, less familiar with. Certainly, I'm not a whale biologist. I love whales. I get to spend a lot of time with whales, but I'm not somebody who could point at a whale that popped up out of the deep ocean and necessarily ID it to sight because there are so many of them, and many of them are ones that are not very frequently seen. But looking at this image, 90 species, we've got our baleen whales on the left and our toothed whales on the right. And as I look at this, to me, the beluga whale really jumps out as a whale that looks really unlike most of the other ones here, aside from the narwhal. So it is different. It looks and acts very differently than a lot of other whales. And it's one that a lot of people are interested in. I'm not sure exactly why. I think possibly because of its otherworldliness, because it's different. And possibly also because for many of us, it may be one of the whales that we first encounter in captivity if we ever visited an aquarium or something as a child. Um, so some of the images that will be coming up in this webinar are taken from aquaria. Whether or not we are a fan of whales in captivity, I am proud to say that in Canada, we do not have whales in captivity for entertainment purposes. We do still have whales in captivity for the purposes of rehabilitation, for example. But I will be showing some images taken from captive belugas simply to be able to better show some of their features because we can control the conditions more for photography in these ways. So let's talk more about what they are. So they are a smaller whale. If you picture that image from before, it wasn't the smallest, but it's certainly not the biggest. A big male beluga will range up to about 18 feet long with a top weight of around 3,500 pounds, and that is a big mature male. And females will top out around 80% of both the length and the weight of a male. They are an Arctic whale. They are found within those ice-covered waters, and they are present around the world in that Arctic area in multiple different populations. The beluga is the most common name for this species, but they're also known as the white whale and as well as the sea canary because of their incredible vocalizations that we'll also talk about. So I will have some images, of course, coming up as well that were taken in the wild. We are quite lucky in the Churchill area during our summer program to have many close encounters with these whales. And when you see them in those waters that are often quite dark and cold, they just really stand out against that dark, cold water as this beautiful, ethereal, just amazing being that really you have a hard time then picturing them anywhere else because they give every sense that this is where they belong. And they are so very well adapted to this Arctic environments. We see them in pods. They're very sociable animals, both with themselves, and they're often quite sociable with humans when they decide to be as well, often coming over to say hello or to check us out. Now, in terms of how long whales that like beluga whales have been in the Arctic, it hasn't been forever. They are a relatively new species, and whales as a group are relatively new as well. So the very first whales arose from a land ancestor around 55 million years ago to 50 million years ago, depending which number you look at. And they very quickly radiated around the Earth's oceans. So by 35 million years ago, we had whale fossils found all over the globe. And by the time we get to that point as well, that 30 to 35 million years ago, we have a radiation, meaning a big split in our whale groupings, giving us what we have now are baleen whales, our filter feeding whales that tend to be quite large, and our toothed whales, who are the whales who have very developed ability to echolocate. So to find their prey even in dark areas using sound. The number of species we have today on Earth that are around 90 really is a fraction of those that have been alive in the past. The fossil record for the whales is a little difficult because, of course, these are oceanic beings. When they die in the ocean, and the fossils may never get to land. So it's been interesting looking back at the evolutionary history of these animals to see kind of how they got here. And what we can say for the beluga whales is that since they have evolved, they have always been a species of the cold. And of the ice. When we think the beluga whale first evolved as a discrete, unique species was around 2.5 million years ago. And around 2.5 million years ago, the Earth was in the grip of a very strong ice age, meaning that those ice sheets and ice caps really extended quite far southwards in the northern hemisphere. So we see beluga whale fossils or subfossils being found in very southerly latitudes, like well beyond where they're found today. And this isn't because they evolved in warm water and have moved into the cold water. they evolved around the ice, but that was a time in which the world was very icy. So as that ice has receded back towards the North Pole and towards those more northerly latitudes, the beluga whales, as well as the narwhals, have just followed that ice further north, with the exception of a very special population called the St. Lawrence River population in southern Canada that just got cut off by this big migration. So with these, both the beluga whale and the narwhal, we think evolved around that same time, around 2.5 million years ago. And they are, despite the fact that they look so very different as adults, with the narwhal having that long tusk on the males, they are quite closely related still, and we have documented hybridization between those two species. So let's take a look at where you can find the beluga today. The belugas have an estimated worldwide population of between 160 to 200,000 individuals. As I noted, they are found in different populations, and we'll talk about the Canadian populations in a bit. We designate them as a species, conservation-wise, of least concern, meaning that overall the species as a whole is doing really, really well, and we don't consider them to be a priority for conservation initiatives. Now, there are some discrete populations that may be endangered or critically endangered or extirpated from an area, but overall the species is doing quite well. As you look at this map, you're looking kind of down from the North Pole towards the circumpolar area here. You'll see two different colors. You've got the yellow area and then the hatched yellow area. The areas with the hatched yellow represent the summer ranges of the beluga, and the overall yellow is their entire range. I put a little blue star where Churchill is located just to give you an idea that it's well within the habitat of the beluga whale. And keep this image in your head for a second, because the next picture I'm going to show you is sea ice. So this is where our beluga whales are found, and coming up right away is our maximum sea ice extent. So this was taken a few winters ago just to pick a random winter of sea ice. And if you held that image in your head, you can really see that where beluga whales are found is where we find winter ice. So they're not surrounded by ice all year. We'll talk about their summer. Certainly, if you come up to Churchill in the summer, you're not bumping icebergs for the most part. It is open water at that point, but beluga whales are a species of the ice, and they are found in areas where we have very dependable winter sea ice. Now, because I get a lot of questions in the summer and in general about narwhals and will we see narwhals in Churchill and where do you have to go to see narwhals, I just wanted to throw up another range map here. So again, you've got that blue star for where Churchill is located. And here you have some different colors. So I just want to point out what these are. Narwhals are, of course, that closely related species to the beluga whale. They are the tusked whale. And their summer areas here are shown in yellow, and their wintering areas are shown in dark blue. The other colors of blue, the medium blue and the light blue, represent sea ice locations. So the medium blue being summer sea ice and the light blue being winter sea ice. So if you thought beluga whales were a species of the Arctic and of the ice, narwhal are even more so. So they are found further north in much more discrete populations and locations. But even though they're in these much smaller areas, they also have an estimated worldwide population of around 160, 170,000. So also doing very well as a species. Okay, back to beluga whales. How does a whale survive in an area that is covered by ice for months and months of the year? In some of these areas, we might be talking about 9 months of ice coverage every year. Now, like I said, most of us are going to see beluga whales in the summer if we see them, but they are creatures of the ice and of the icy waters. So I mentioned before that their scientific name, the Delphinapterus lucus, means dolphin. So white dolphin without a fin. You'll notice looking at the backs of these belugas going down for a dive here that unlike the majority of our other cetaceans, there is no dorsal fin. So this is similar to the narwhal and the bowhead whale. Both of those are also whales of the Arctic. None of those whales have dorsal fins. And if you can imagine like a whale here swimming in ice-covered waters and having to maneuver around this very dynamic habitat with lots of three-dimensional structures coming out underneath the water, having a giant, fin sticking off your back is not really advantageous for moving through this habitat. So none of our Arctic whales have any dorsal fin. They do, however, have something called a dorsal ridge. It's an area of thickened keratinized skin that runs along the midpoint of their back. And using their strength and that strong ridge, they are able to break ice up to around 8 inches thick. So even though they're maneuvering in this icy habitat, they're not without ways of dealing with the ice, at least up to a point. Because they don't have that keel along their back, they're not fast swimmers. They're maneuverable. They're very, very maneuverable, but they're not fast. Their fastest recording swimming speed was around 20 miles an hour, but more normally they're around half a mile to about 5 miles per hour. So what I would call a very, very gentle walking speed. Their longest recorded dive was 23 minutes. But if you think about that in a different context, the longest recorded human dive is longer than that. And on average, like beluga whales and humans can hold their breath for about the same length of time, which is really wacky to think about. To live in a habitat where you're still having to come up for air every minute or two, even if certain individuals have that capacity to dive longer, most of them do not. So they are a shallow water whale. As I mentioned, they are very maneuverable. And aside from the lack of a dorsal fin, the other reason that they're maneuverable is that their neck vertebrae are not fused into a single piece. In most other whales, the baleen whales and most of the toothed whales, the cervical vertebrae, so the neck part of their backbone, are fused into a single piece so that they can't turn their heads side to side or up and down. And if you think about it for those really fast-moving dolphins or things like orcas, they have to be able to keep their head aligned because if you're going that fast through the water, you need to be a very streamlined unit. Beluga whales maneuvering very slowly around icy waters, they need the advantage of being able to turn on a dime and turn around and look up and look down. So they've got this ability to still rotate their head. And we certainly see in the summer, many of them will swim up beside us and they turn their head and they look up at you and you're like, oh my gosh, I just made eye contact with the whale. Because they are able to do this and they are curious animals. They have small fins relative to their body size. This is primarily to control heat loss. So as they're sending blood out towards their extremities, that's obviously heat that's being lost to the cold water. So because they're not moving fast, they don't really need big fins, and they're able to reduce their heat loss that way. Now, this next one is not my image, but I love it so much. It is my goal someday to purchase a print of this image and have it on the wall because I think it is just so fantastic. This is an image just taken of a beluga whale breaching near Somerset Island, showing off their extreme abdominal muscles. Just kidding. Those are fat rolls because a beluga whale is about 50% fat by weight. So of our like big male, around 3,500 pounds, about 1,700 pounds of that will be just fat and blubber. So blubber is very important for Arctic animals. It works as both a food source. They're able to put on extra fat and then metabolize it at different times of year. For example, during the migration when they might not have time to stop and feed, for times when the females are calving and nursing and might not have a lot of time to feed, but also it works as a really important insulator. And they're actually able to a certain extent, control how that blubber sits on their body because it is both, it's considered part of the musculoskeletal system. There is some muscle attachment within the blubber as well. So beautiful whale there. How does a whale get that fat in the Arctic? Just wanted to quickly run through the food chain for you because of all the things in the Arctic that I think are, really the most impressive, the fact that you take this giant piece of sea that to the naked eye is not very productive at all. And you end up with like bowhead whales, narwhals, beluga whales, polar bears, seals, walruses, all these really, really fatty animals. And all of this comes from the base of the food chain, which would be the algae growing both within the water and within the sea ice itself. So even when everything is iced fully over, we have algae growing within that ice structure. It tends to grow along the bottom of the ice where it's exposed to the water and can get nutrients, but ice that's not so thick that it fully stops all light transmission coming through. So you can see here on this ice core on the left, that ring of brown is actually brown algae that is photosynthesizing within the ice. And if you look at it underneath the ice, you might not think it looks very impressive, but it is because of things like this that we can have beluga whales and polar bears and narwhals, because these primary producers are creating the basis for the larger species that we see within that food chain, that trophic chain. It's kind of hard to believe sometimes, but I mentioned that there's many, many whales that used to exist and no longer do. The largest whales that we've ever had on the history of the planet Earth exist right now. And the reason that we're able to have large, large filter feeding animals like this is because, again, of the algae being so very productive at this point in time. And why they are very productive at this point in time is because we have a lot of water that's not too hot, and there's a lot of landmass that's not just along the equator, but it's oriented really well north to south, so there's a lot of nutrients coming off at different latitudes. And if we didn't have this arrangement of continents and this arrangement of temperatures, we would not be able to support these big whales that we have in the ocean today. So just a little aside for you there, but I think it's just fascinating. If you look here at the oceans, this is a map of where the primary productivity, meaning the amount of photosynthesis happening, turning energy from the sun into sugar-based energy and carbon-based energy. You can see that our highest amount of productivity is not around the equator. It's not around the tropics. It is in those polar latitudes where we're getting lots of sun in the summer, where we have nice cool water, and where we have access to nutrients coming off the land. So this is why whales will migrate up towards these areas in the summer, and it's why we're able to support a food chain that has all these big, big fatty animals in it. So as the ice melts, the algae will be released into the water and they continue to grow and proliferate. This is usually when there's a lot of sunlight and a lot of nutrients running off the land, with the snowmelt coming as well. And we often think of algal blooms as bad things. Certainly they can be, but these are good blooms and they contain good algae that are part of this polar ecosystem. These algae then go on to feed other organisms like copepods and amphipods. These are, they can be pretty small, kind of plankton-like organisms, or they can be larger. They get to about the size of your thumb. But when you look at these, we're already starting the fat chain transmission. So if you look at the center of this organism, it's got this long kind of shiny part to the middle of it here. That is their fat storage system. And as we go on, all the way from our algae through our copepods and amphipods and up to our fish and other mammals, then we're seeing this fat being kind of the currency of the Arctic and how we can go on to feed all of these other animals. So this fat will then go on to feed the many fish and other organisms that our whales will feed upon. These are capelin. They're a small forage fish in the Arctic that will spawn in huge numbers into the Arctic rivers. They're certainly not the only food that belugas eat, but they are a main prey item of the belugas. And when they spawn, you see them just in these incredibly huge numbers. Um, there was a few years ago, I had a GoPro with me in the summer, and there were beluga whales beside me in a feeding frenzy, just moving all around, and you could see flippers going every which way, and tails were coming up in the air, and they were very busy eating. And I stuck my GoPro in the water, and all I could see with that GoPro were just capelin swarming around in this big ball. So it's a really important food source in the summer for those whales. And then it's a pretty short food chain. We go right from the capelin and other fish to our beluga whales. So they are, as we said, they are toothed whales. Their teeth are not used for biting prey, but they're more used to hold them in place. As whales age, our older whales do lose their teeth, and they are still able to feed fairly effectively without their teeth as well. They're very peg-like. They don't tear or cut meat at all. So they'll eat capelin, but they'll also eat other fish like Arctic cod and herring, char, a whole variety of mollusks and crustaceans, um, things like they'll eat squid, they'll eat starfish, they'll eat various mollusks, they'll eat a lot of shrimp. So depending on the population of whales and what's available to them in their habitat, they will eat pretty well most things that exist within the top of the water column. They feed, as I mentioned, through suction feeding primarily. So those teeth are not used to grasp prey, or rather to bite them, but to hold them in place. And they are able to move their lips around to create like a little puckered lips, to suck prey in, and also to blow water jets to dislodge things from the bottom um, of the sea there. So this is an aquarium whale demonstrating that they can blow bubbles. So if you can move air in and out like that, it's one way and their main way of feeding. They also do bubble blowing for play and for other reasons as well. So they're very used to using their mouths for various things, including socialization. Now, in terms of how they find their prey in those dark Arctic waters, certainly in the summer, they may have 24 hours of daylight, but in the winter, they are still feeding and they may have 24 hours of darkness. So that big evolutionary split 30 million years ago gave us our toothed whales and our baleen whales. And it really is our toothed whales that went on to develop really strong ability to echolocate. So this is using sound waves to push out away from the whale's body. Those sound waves reflect back off things underneath the water, which might include schools of fish, or it might include things like ice or underwater rocks. And then those sound waves come back at the whale, and they are able to use those sound waves to perceive their underwater habitat. So what happens there is that the beluga whale has a huge repertoire of sounds, including echolocation clicks that are generated at quite high frequencies. So here, if you look at this image, they have their blowhole on top of their head. Underneath their blowhole is their nasal sacs and their nasal lips, and they will move air through those nasal lips, basically like a trombone player moving air through a trombone by kind of putting your lips together and buzzing. The sound waves will then go out through their head, interacting with the melon. The melon is not part of their skull. It is a big fluid-filled sac that they are able to use the muscles around it to control the shape of the melon. And using those muscles to control the shape, just like, if you have a pair of glasses cut to curve light waves, the melon will bend those sound waves in the direction and need that they want them to go. So they are able to really, really focus in those sound waves to a very tight beam. Those sound waves go off, rebound off of something, come back, and how they are going to perceive those sound waves are through their lower jaw. So beluga whales do not have external ears, which makes sense because they're underwater. If you ever want to try something out yourself, stick your head underwater and ask somebody to talk around you or make a noise when you have your eyes closed. we are not able to perceive directionality underwater because the speed of sound through water does not allow us to pinpoint where things are coming from. So the same would be true of whales. So instead, they force those sound waves to go through bone and fat. So the fat in the lower jaw is a matrix of fat and air pockets, and it then allows directionality of hearing. So depending how fast sound is traveling and when it hits one side of the jaw versus the other, same as us turning our heads to find out where somebody's talking, so our ears can point at them. The beluga whales can do the same thing with their jaw. And then those sound waves are transmitted up through those fat-filled cavities towards their inner ears. So very, very cool system shared by all of those toothed whales that went on to develop echolocation. Whew, those are not the only sounds the beluga whales make. They do other vocalizations as well, and they are very, very, very chatty whales. I mentioned before that they're social, so they talk to each other, they talk to their young, they communicate. So they communicate with their, like I said, with their young. There's so much that if you come up to Churchill in the summer, we'll talk about in terms of vocalizations, because I think to a lot of us, it is one of the more fascinating things as to, the level of, you know, of communication that happens within this species. They are certainly talking more than we ever thought that they ever could. Now, they have a huge ability to perceive sounds. So this is the sound curve of a number of marine mammals. The green circle represents the ability of beluga whales to perceive sounds at different frequencies. To compare, the blue box that's going to come up right away is human frequencies. So we hear to about the same level at the lower end of the register, but then all of those marine mammals, and especially things like the beluga whales, just blow us out of the water where it comes to those top frequencies, and they chatter quite high in the sound frequency scale. Now, so much so, like, it took us a while to figure this out, because when humans are developing things like recording devices and transmission devices, and we're trying to figure out, what does this beluga whale word mean? What does that beluga whale sound mean? Some of the early studies just completely failed, for one reason being that our human speakers are not designed to broadcast at the frequencies at which beluga whales hear. So when we tried to send out calls to them, for example, to see if they would react, we were only sending a portion of that word that they would have been able to hear. So they did not react as you could expect from that. Let's talk about how beluga whales kind of go through their life cycle. Now, with the life cycle, certainly a lot of our knowledge is from, again, those captive beluga whales, but we have a lot of traditional ecological knowledge, as well as knowledge from, naturalists and scientists who are out there on ships and studying these whales, either directly or through things like probes in the water to collect sounds and information that way. So here we have a beluga whale mama and her baby. This is a very, very fresh baby. So when they are born as singletons. They are born tail first, and when they're born, they're about a third to about a half of the size of their mother in terms of the length, and they're born in the summer. When female beluga whales are sexually mature, this is between around 4 to 7 years old, males around 6 to 7 years old. And they are born dark, usually like a peanut color or a bit of a kind of a dark gray, and then they very quickly darken up to be a very dark gray. As they move through their life stages, by the time they are sexually mature, they should be either pure whites or very close to pure white. Their estimated gestation is around 13 to 14 months. So it is a pretty long gestation period. We don't know if they are actively gestating that whole time, or if there is a delay in between fertilization and implantation. But this means that they likely mate in the late winter or early spring, go through a full annual cycle before giving birth the next summer. Let's just move on. So I've got just a couple pictures here to show you what they look like in the wild. So this one coming up here is a very, very fresh newborn. So we start seeing these around, mid-July or so as the calving happens. And when they are fresh, when they are newborns, because the distance from their nose to their blowhole is so small, unlike a lot of other times when adult whales come up to take a breath, their face stays underwater. With the newborns, because they're so small, their face tends to come all the way out. So when we get a picture of a face, it's usually a picture of a newborn face, and they are very, very cute. Between the time when they, become pregnant and the time where they finish lactation, it's about a 3-year gap between pregnancies. And we think that a new pregnancy probably triggers the end of lactation for those calves. They're dependent on milk for about the first year of their life, and they will continue to nurse kind of later on, depending. We don't have great information on whether or not lactation continues while pregnancy keeps going. Here's another image of a calf with adults coming up here. So this is still a very young calf, but it's no longer a newborn. So they've gone from that kind of peanut or caramel color to darkening up very quickly. And you can really see that color contrast between a very young whale and an adult whale there. Now, in terms of how long they live, we don't actually have a good answer for how long a beluga whale will live in the wild. They are very difficult to age. We don't have a consistent way of aging them. With other toothed whales, sometimes we use tooth rings to count to see how old they are, but beluga whales do not appear to lay down consistent rings in their dentin. So we think that they live about as long as humans do, so up to around 80 years old, but the jury is very much still out on that, and they might live longer or not. Now let's talk about where they are. So here's Canada, and here's all of our beluga whale populations within Canada. Again, I've got a little star there in the Churchill area. So the Churchill beluga whales belong to the Western Hudson Bay population, and that is a very, very robust population with around 60,000 individuals just in that population. Canada has 7 different populations that we recognize, and populations are just useful to talk about from a management perspective. It's not that they're fully separate, that individuals will never cross over or mate, but that overall an individual is more likely to stay there. They tend to return to the same area they were born. They tend to mate within their own populations. And so population recovery and population management depends on our ability to kind of be able to tell where these populations are. So there's our populations there. Our southernmost one, if you look at number 1 down in the lower right-hand corner, that is the St. Lawrence estuary population. It's what we call a relic population, meaning that it probably shouldn't be there, and it probably just got left behind when all of the other whales followed the sea ice up, and the St. Lawrence population said, we'll just stay here, I guess. Seems good enough. So again, looking here at summering areas versus overall habitat, the black is the summering areas, and then the gray represents the entirety of the beluga whale habitat. You can see that they are coastal, so they don't go out into the middle of the bay, for example. They don't go between islands. They like in the summer to be within the river estuaries, and then in the winter they go into other habitats that are more likely to be ice-free. So here is looking at the Western Hudson Bay population, our Churchill population. They are in this black zone here in the summer. So the different rivers there, including the Churchill River and the Nelson River, will all have different groups of belugas come to them, give birth, feed, molt, have a great summer time, and then they head back towards their wintering areas, following the coastlines of Hudson Bay in either direction, depending how close they are to either side, and then they end up within the Hudson Strait area for the winter. Again, remember, this is a long migration. These whales are not moving fast at all. And why are they going up that way? Well, they're not seeking warmer water. They are seeking water that is ice-free enough that they are able to continue breathing through the winter months. So this is a circumpolar map here of what are called polynyas. Polynyas are consistently open areas of water surrounded by ice. So this is just because of different currents and different conditions within these areas. These dark purple zones are areas that are known to stay open through those winter months. So they're going to be great places for beluga whales and narwhals and walruses and seals and all of our marine mammals that still require, you know, oxygen and air to come up and be able to breathe. So that's why the whales have to leave the Churchill area in the winter. Now, if you look at the light purple on this map, though, you'll also see that there are some what are called shore lead polynyas. So these are areas that are more kind of itinerant. They come and they go, and they're not always in the exact same place, but areas where there tends to be areas of open water along the shore. And we know that beluga whales use these, especially male beluga whales, because they are more tolerant of higher ice-covered areas than females with calves. And as soon as the ice breaks up on those rivers, they move in so quickly. So they've obviously been following those shore leads down. Now here's another whale just looking at us through the water. The Churchill whale population is between 3,000 and 5,000 estimated. And there are many of them. Like, one of the things I really love about our Churchill summer program is that we're out on the water nearly every day, and we're able to see whales engage in a lot of different behaviors. Certainly sometimes we go out and the whales are like, they're sleepy or they're just feeding and they're not interested in saying hi. But we're out there so often that, you know, the whales, at some point we will have curious whales who come over and check out the boat and want to see what's going on. Now, like I mentioned, they arrive, usually the males arrive first. This group that you can see here on the screen, I can tell you right now, is a bunch of mature males. I know they are mature because they are all white, and I know that they're males because males are found in male-only groups. So we have two social structures mainly. We have what we call our bachelor pods, so they're just mature males, and then we have our family groups. And the family groups will be made up of one or more female, like mature females, with related offspring. And those offspring will stay with their mom even if they're no longer nursing until they are sexually mature themselves. Why they bother going through this whole migration, right? They're coming in to feed, they're feeding on those capelin runs and for other fish. They're coming in to calve. As they come into those rivers, it's a more sheltered area. They are able to give birth in warmer waters with a greater amount of food around them. And they also come in to molt. Beluga whales, like we're mammals and we're losing little bits of our skin all the time. All of us mammals do. Beluga whales lose it all in one whack. So in early summer, they'll kind of be a little bit yellow and they might look like they're peeling a little bit. And then they come into these estuaries where there's a lot of gravel and sand on the bottom, roll around and slough off all of that year-old skin. And then they pop up and they are white again instead of having a little yellowish cast. So here's just some people looking at whales on the boat here. Just wanted to talk about this particular population. So our Churchill River population, as I mentioned, is part of the Western Hudson Bay population. They're really interesting in that they actually demonstrate an attraction to boats. Not every beluga whale does, but beluga whales are clearly able to communicate and teach their young. And the Churchill population has had a very good relationship with the boat operators and with the tour drivers and with anybody else who heads out on boats, because there's no or very little harvesting of beluga whales in the areas. They're not afraid of boats. They don't disappear when boats come around. And they actually demonstrate that attraction. So they like coming over to check things out. So this population is not considered to be at risk. They are part of that Western Hudson Bay population and doing overall pretty well. Now, I do want to talk about conservation concerns for the beluga whales because we do, as we said, we mentioned that beluga whales as a species are doing really well, but like a lot of Arctic animals, they are facing increasing threats both from climate change and the loss of habitat, but also from human incursion into areas that we traditionally haven't really gone into. So this here is these are two maps showing different shipping lanes in the Arctic Ocean. And here we have the blue being regular vessels and the red being icebreaker class vessels. So in kind of a 10-year period in the early 2000s, all of those vessels had to go around the major ice concentrations in the center of the Arctic Ocean. But we estimate that in not too long, we're going to have low ice conditions or no ice conditions through the summer in those areas. And we're going to see shipping going through areas that have never really had motorized shipping go through them before. And all of these new shipping lanes are going to be in really prime beluga and narwhal habitats. So there's our map of where we find our whales, and as I just mentioned, it pretty well fully overlaps with where those new shipping lanes are going to be. A major concern of a lot of WWF Canada and WWF North is really trying to preemptively reduce impacts of shipping on all of the marine mammals found in this area. And this isn't exclusive to beluga whales, it includes our narwhals and our bowhead whales and things like walruses and seals as well. All of these animals, if you remember that chart I was showing, are they have good hearing within a very large range. Water is very good at conducting sound, and all of these animals, but especially our whales, have had a long history of communicating within their pods, communicating in some cases like sperm whale sounds. Not that we have sperm whales in the Arctic, but those can be heard halfway around the Earth. And really, the main impact of shipping is not so much the ships themselves, but the noise that the ships make. So different vessels certainly make different noises, but they overlap completely with the hearing range and the noise production range of the beluga whale. And we've seen in areas like the St. Lawrence River population, which is a high shipping area as well, that how whales adapt is by changing their tones. So they do things like they repeat themselves, or they get louder, or they actually will move their speech higher into like a higher frequency range, because shifts, if you look at this chart here, are louder lower and not as loud within the higher part of the range. And it's really analogous to us all of a sudden having to move through an area that's suddenly dark or through heavy fog, right? This is how they perceive their habitat. It's how they catch their prey. And when we put in ships and new sounds into these areas, they do struggle to be able to effectively communicate with other members of their pod. A major strategy to kind of preemptively reduce these is asking ships to stay out of really important areas. So this is from a WWF Arctic document kind of showing preferred shipping lanes. And we see that, people are often really good. And most folks, whether it's folks who live up in the Arctic or whether it's people who come up to work, most people really love the wildlife. And in a lot of cases, we can really mitigate what we're doing simply by, for example, agreeing to move all of our shipping traffic 50 kilometers over in that direction. And so we have seen a lot of good adherence to strategies like this, but it's certainly something that we're going to be continuing to examine and work on into the future. Aside from shipping, depending on the different populations we're talking about, whales have different pressures put upon them. There are some whale populations that are harvested for traditional food, but there's also other things that go out and get whales, and there will be a little bit of blood in this next photo, just to warn you here. Beluga whales are predated upon by polar bears. Polar bears aren't often lucky enough to get beluga whales, but when they do, it's a pretty good day for that polar bear. They can hunt them both from the shore of the water when conditions are really good, as well as from the ice when whales get stuck in a small opening of ice. And we've recently seen killer whales, orcas, moving up into the Arctic as well. So these are the natural predators here of our beluga whales. Um, they're really they're really just something else, those whales. They live with us in areas like the St. Lawrence River, even around ships. It's possible to have a very healthy population of beluga whales, though the St. Lawrence population certainly has its own struggles. Um, but one thing I do want to point out with ships is that there are those areas where they are actually attracted to ship traffic, and it's really important that we both recognize that and we respect that, and we make sure that we're doing safe behavior in those areas. If you are not traveling to Churchill this summer and you really want to watch beluga whales, there is a project out that live streams beluga whales from the Churchill area every day in July and August at high tide. So whatever that 2 hour period around high tide is, they will be live streaming, and the rest of the time they are on as kind of repeats. So you can go online and you can watch the whales and kind of get an idea what you might be able to see if you come up to Churchill. They have both an above water camera and a below water camera. So it's a pretty neat little thing. I actually, once July hits, that's what I do as well. So you can find that on the website explore.org. And if you have extra time on your hands, there's also some citizen science projects that run off of that data. It's not just about looking at fun whales. You can use that camera to look at whales just for fun, or you can actually sign up and help with age classification and population classification of these whales as well. So with that, I know we're getting towards the end of the hour here, and I really want to leave time for questions. So I'm going to hand things back over to Rob here for anybody who has questions about beluga whales.
All right, thank you so much, Eleanor. Now, before we dive into the questions, I would like to remind everyone that you can submit your questions via the question field in your control panel. All right, let's get to some of these questions. So, are there beluga who remain in Churchill area through October?
Uh, so beluga whales will really appear in the Churchill area nearly as soon as that ice breaks up. I have not yet heard reports of beluga whales right now, but the river did just break up, so the first males should start showing up anytime now. As we get into October, um, I'm up in Churchill a lot of our seasons, and I work hard to see beluga whales because I love them so much. I have always been able to spot at least one beluga whale in October, but that really does depend on your dedication to not looking at anything else for a while and just watching the river for beluga whales. There's usually a couple of pods that will kind of stay there until early to mid-October. By late October, they really all should be gone. And one of the best ways to get your best view at beluga whales at that time of year, best chance of seeing them, would be by air. So, like a helicopter flight, for example, might have the greatest possibility of spotting beluga whales. So, yes, there are whales that remain into October. The mothers and calves are well gone by then, and it's really just those last pods of males that will remain. And there are very few of them, but there are some.
Great, thank you. So, are there any theories regarding why the St. Lawrence Seaway population didn't move?
I don't know of any theories as to why they didn't move. The theory, the real theory is that they would have been part of a larger population where likely at some point, probably around 10,000 years ago, roughly, Part of the population moved north, likely becoming some of our new populations, like joining up to the Western Hudson Bay population or the Ungava Bay population. But the St. Lawrence population did not move. And there's actually some really interesting genetics where it comes to studying those populations, because when we're looking at population management and when they're looking at like drawing lines around those populations to ensure that we are best protecting them, they want to make sure that they're actually protecting populations correctly. So one of the earliest studies done in Canada was a genetic variance study between all 7 populations to see how much overlap there was between, Ungava Bay, Eastern Hudson Bay, Western Hudson Bay, the St. Lawrence Estuary. And pretty well everything kind of in northern Canada was definitely related. The further west you got, the less related they were. And then way off in the corner, there's the St. Lawrence Estuary population, very, very genetically distinct. Certainly at this point, has real conservation struggles because they're in a very high impact area, lots of shipping traffic, lots of pollution, lots of human activity. Um, their population was in fact culled by people. About 80 years ago, they removed probably 80% of the population, and it's never really recovered to its original levels, although they've been relatively steady since that time. But it is really interesting to look at those genetic variances between populations and say, like, maybe, perhaps if we look at movement over time, that population may always have been separate, and it may not actually have joined up to be part of the part of the colonizing populations of any of the other areas. They might have just been there, none of them left, they all just stayed there, and it's before humans came in, it was really good habitat. And I shouldn't say humans, I should say before, modern North American civilization came into that area, it was very good habitat. Lots of fish, ice coverage in the winter, open in the summer. Why migrate if you don't have to? And so they just stuck around, and it just unfortunately for them turned out to be a major shipping lane for humans.
Great. Thank you for your answer. So, do we know if belugas only communicate when necessary, or do they also communicate just to be sociable?
Oh, that's a great question, and I love all beluga whale communication questions. I guess it depends what you consider to be necessary. Like, do they gossip between each other? I don't know the answer to that. And we haven't differentiated all their calls. There is a researcher who's been doing a lot of research on beluga whale calls, and she's been able to differentiate at least 17 to 20 distinct calls and what their meanings are, which blows my mind that we're able to do that for another species. But those calls have all been pretty, like they've been for reasons, right? They've been a location, or they've been towards another whale, or they've been expressing some kind of important thing. The most common contact call that we hear is something called a contact call, which is really said between primarily mothers and their calves, but also all members of the pod who are looking for each other. Each whale has their own contact call. So that is the call that is associated only with them. And to my ear and your ear, they would probably all sound pretty similar. But to a beluga whale or to a researcher studying beluga whales, each contact call is distinct to an individual whale. So whether you want to call that their name, they definitely are able to direct communication. They're able to know other whales' names and be like, "Oh, my mom's calling me," that kind of that kind of thing, right? They can call their young over. So I look forward to more information around beluga whales and what all of their vocalizations mean. What I would say from a point of view of somebody who listens to them a lot is that there's so much chatter happening. Like when you drop a microphone under the water and you can just hear all the noise, I don't think it's just necessary noise, because that's a lot of talk. It's a lot of noise. for an animal to make. So there's a lot going on underneath the water. And I'm really hoping in my lifetime that we're able to decode a lot more of it than we have now.
Fascinating. All right. Is the flexibility in their neck the primary reason why they have such a wide vocal range?
Oh, it is not actually. So the flexibility in their neck, there's no vocalizations like you and I have a voice box, right? So we talk basically from our lungs, through our throat, out our mouths. Beluga whales cannot vocalize through their mouth. They can only vocalize through their nasal sacs, basically. So they don't have a voice box. They're not able to make any noises that way. Um, so the flexibility of their neck doesn't make a difference, but the fact that they have that, you can go onto YouTube, and I hope you do it right after we're done here, and search up beluga whale moving melon, because they are able to just like move that lens so much more than you could ever think. Like they have incredible control over not just the tones they're producing, but how they direct those tones and how they shape those tones. They're built to be vocal. They're just built in a different way than you and I are.
Okay. Very interesting. Thank you. So the Arctic area that will open up for shipping, it's bordering on different countries. Does WWF or somebody work on some sort of international treaty?
Yeah, so that's a really interesting question, and it's certainly stuff that's ongoing right now, and we've seen a lot of movement in that in the last few years. WWF, as well as organizations like Parks Canada and the Inuit Circumpolar Council, have all been working to really identify priorities for protected areas. And priorities might be because of traditional use, they might be priorities because we've recognized an area called the last ice area, which will be the last place to likely have ice through the summer months, even as we see extreme climate change changing the Arctic. And priorities also involve, especially like important summer and calving areas for our marine mammals. So we've seen in Canada in the last 10 years, I think it's now 3 new marine protected areas within Canadian waters. And we're also still in conversations around, international waters and waters that might be administered by different countries as well, to best be able to manage the species, all of these Arctic species, instead of doing it one country by one country, organizing it all together. And WWF is very much at the table for those types of conversations.
Great. Thank you so much, Eleanor. Unfortunately, that will be the last question that we do have time for today. So I'd like to throw it back to you for any closing comments you may have.
Thank you, Rob, and thanks everybody for coming by. I hope that you enjoyed this and learned something. And whether or not you're coming up to see beluga whales this summer, I highly invite you to sign on to that website and watch them from your home either way. They're pretty amazing animals. So thanks very much for coming by, and see you again next time.
Eleanor, thank you so much for taking the time to present for us today. And I'd also like to thank everyone who tuned in today. So if you are interested in information on how you can travel with NatHab, give us a call at the number on your screen, or you can send us an email at info@nathab.com. Our adventure specialists are happy to help you out. Join us tomorrow for our next daily dose of nature. You can check out this week's lineup, including our registration links, on our website at nathab.com/webinars. We did record today's presentation, and we will have the replay available on our website soon. With that, I will conclude today's webinar. Goodbye, everybody. We'll see you next time.